In this course, we work with three possible graph shapes. They are linear, parabolic, and hyperbolic. If we have linear, it looks like that. If we have parabolic, it looks like that. This is a parabolic curve. And last but not least, if it's hyperbolic, that shape, it looks like that. The relationship between y and x for a linear graph is that y varies directly with x. The equation would be y is equal to kx, where k is a constant. The relationship here is that y varies directly with the square of x. The equation is y is equal to kx squared. For this one, the hyperbolic, y varies inversely with x. The relationship is y varies inversely with x. The equation would be y is equal to k over x, where again k is a constant. By the way, if you plotted y versus x squared instead of y versus x, you would get a linear relationship. Again, that's because y varies directly with x squared. So the equation y equals kx squared shows that y is directly proportional with x squared. So plotting y versus x squared would result in a linear relationship. Now, in this course, we don't work with y and x like this. In this course, when we do labs, x is usually the time axis. So call it that. And y, at least in the beginning of the course, is either x or y. Okay, but we start with x, and that stands for position. So the relationship states that the position varies directly with the time for a linear shaped graph. The equation, you would write the position is equal to k times t. Here, y varies directly with the square of x. In this course, this will be time, and this will be either x or y. So it's the relationship is that the position varies directly with the square of the time. Position varies directly with the square of the time. So we use x and t or y and t rather than y and x. Okay, and then down here, we'll do a lab where the y will be the acceleration and x will be mass. So the relationship is that the acceleration varies inversely with the mass. The equation then would be the acceleration equals k over m. Now what's k? Well, in this case, k turns out to be the velocity. The slope of an at position versus time graph is velocity. Here, the k turns out to be 1/2 the acceleration, because when you have a graph that has the shape of a parabola, and it's a position versus time graph, that shows that there is a constant acceleration. So the k turns out to be 1/2 the acceleration. And then down here, the k turns out to be the net force. So this is Newton's second law.